Okay, we're doing linear equation solving. Nothing that you have to be afraid of. You probably did this last year. So let's just review. Linear means line. So these equations that we're going to be solving means they're a line. And we're going to show you something cool later on Desmos about it. Some of our answers are not going to be so pretty. Don't be afraid. Fractions are our friends. We can get some ugly answers sometimes. All right, so we're back to solving these equations. And remember, you can do them a couple of ways. I'm going to do the traditional way first. So the traditional way means this. I've got to get to this x. So I move everybody away from x, and I undo things. So see this -3 right here? If I add 3, that undoes the -3. So that leaves me with 4x equals, well, what's a -17 plus 3? -14. All right, still got to get to this x. So who's still gripping very hard onto that x? That 4. And it's being gripped by multiplication. So I do the opposite, or the better math phrase is the inverse of multiplication, which is division, to both sides. Remember now, I told you how to shortly and quickly divide some number by 4. We take half of it twice. So half of -14 is -7, and half of -7 is -3.5. Now we can always check, as we should. All right, well, I'm going to do a little distribution here. I'm going to break up 3.5. So -3 times 4 is -12. Half of 4 is 2, so that's going to be -2. And then we still have that -3. -12 minus 2 is -14. -14 minus 3 is -17. So I did indeed get the right answer. Now, if you like the traditional way, great. If you like the little chart way, you can do that also. You can say, all right, I started with x, then I multiplied by 4, then I minused 3, and that got me to -17. And then you can undo each operation, and that will get you the same answer, whichever way you like. I'm going to stick more with the traditional method now. So I've got two things going on here. I'm adding 6, and actually here I'm multiplying by -5/2. All right, so let's undo this step by step. -5/2 times x. We then added 6 onto it, and we got 1. So the first thing I'm going to do is -6. So I have -5/2 x. These cancel out. 1 minus 6 is -5. Now, hopefully you remember from last year, how do we get rid of a fraction quickly? Well, we multiply it by its reciprocal. And if you don't know what a reciprocal is, take time to write this down. It simply means to flip the fraction. And notice what happens here. Since it was being multiplied, we do have a division here to undo the multiplying. And since it was dividing here, we have a multiplication to undo that division. Numerator, denominator cancels out. The negative makes a positive, and I'm simply left with x. Now remember, what I did to one side, I have to do to the other. So I have to multiply this side by negative 2 over 5. Numerator and denominator cancel out. Negative and a negative cancel to a positive. So my answer here is 2. So this should be something that should be big in your notes. If you did not understand multiplying by a reciprocal, it may be new to you, but I don't think it is. So let's check. And we say 2 is our answer, so I'll put 2 in there. And we should get 1 as an answer. Well, right here, a denominator and a numerator cancel out. I still have the negative. It doesn't cancel out with anybody. So I have negative 5 plus 6, and that does indeed get me 1, which is what I was looking for. All right, example 3. Wow, this is a long one. So let's dissect it bit by bit. I'll throw that old fence down the side here so we can look at the left side and the right side. All right, so first off, I'm going to look at the left side. So what do I see here on the left side? 9 minus 6 times. Ooh, I've got some distribution I can do right here. Nothing with the 9. I distribute the negative 6. Okay. Now I'm going to look at the right side. 2 times, oh, I got some more distribution I can do here. 2x minus 8 plus 27. Okay, now it becomes a game. And when I play this game, I want to get all my variables on one side and all my numbers on the other side. All right, so what does that mean? All right, so I'm going to start moving all my variables to one side. So I could do this very systematically. 9. That is not a variable. It's a number. So it gets moved to the other side of the problem. But when it jumps over, remember, we're undoing it. So we are really minusing 9. So its sign changes. Minus 6x is a variable, so it can stay on the left side. 6 minus gets moved to the number side. And remember, when it switches to the other side of the problem, we're going to do its inverse operation. So it goes from minus to plus. All right, what's next? The 2x. The 2x is a variable, so it goes to the other side. But we'll do the inverse. So since 2 is being held on by addition, it changes to subtraction. Make that blue so we can show that we changed it. Negative 8 gets to stay. Positive 27 gets to stay. And we have this negative 9. And we have this positive 6. Okay, so now I can combine like terms. Negative 6x minus 2x is negative 8x. All right, let's get some adding and subtracting going on here. I owe $8. I have $27, which means after I pay back the $8 I owe, I have 19. 19 take away 9 is 10. And 10 plus 6 is 16. So this side turned out to be 16. This side, negative 8x. And I have one step now. How do I solve this? It's just asking me negative 8 times what gets me positive 16. And that answer is a negative 2. I can do that by dividing both sides by negative 8. All right, so let's check this. 9 minus 6, parentheses. In for x, I say it's a negative 2, plus 1, and that should equal 2 times, my x I believe is negative 2, minus 4, plus, I'm going to run out of room here, 27. All right, I can do it. I'm going to do parentheses first. Negative 2 plus 1 turns out to be negative 1. Order of operations says I have to multiply here first, so that becomes a positive 6. So I get 15. Now I better get 15 with this over here too. PEMDAS, do my parentheses first. Negative 2 minus 4 is negative 6. So 2 times negative 6. And then I'm going to add 27 onto that. 2 times negative 6 is negative 12 plus 27. I got it. 15 equals 15. All right. Now I want to show you something here. Give me a second. Remember when I said that these were linear? Well, this is a line. And I'm going to go to my friend Desmos, the calculator, and I'm going to type that in, 4x minus 3. Now you may be saying, wait a second, Mrs. Trulin, there's more to it than 4x minus 3. That's right. It says it equals negative 17. Well, I'm going to look at these as two totally different equations. See what happened there? When I typed in y equals negative 17 and 4x minus 3, this is what I got. This is the line negative 17, and this is the line 4x minus 3, and they cross right here when the x value is negative 3.5. Hey, isn't that what we got for an answer right here? X is negative 3.5. I'm going to do the same thing right here. I'm going to look at this as two separate lines. I'm going to look at this as a line, and I'm going to look at this as a line. And now I'm going to go back to my friend Desmos. All right, so I'm going to type the first one in. Negative 5 halves. So negative 5, where's my division? Divided by 2. X plus 6, and then this is going to be the line y equals 1. Now let's come back here, and we said our x value should be 2, so that when these two lines cross, the x value should be 2. Well, I'm going to come over here, I'm going to move my picture so I can see, hey, look at that! Here's my negative 5 halves x plus 6 is in red. And then y equals 1 is in blue. And look, they do cross where the x value is 2. Pretty sneaky. And I can do the same thing right here. I'm going to clean up this page just a little bit. And I'm going to type this in. Type one side in. And that is the side 9 minus 6, parentheses, x plus 1. And now for my second line, I have 2x minus 4 plus 27. So let's see. 2 quantity x minus 4 plus 27. All right, so where should they cross? When my x value is negative 2, we said, right? We said when x equals negative 2. All right, let's see. Let's drag this down until they cross, and look at that, the x value is negative 2. So we are going to learn how to use this method when we get our graphing calculators, which we're going to be getting pretty soon. Okay, so tomorrow in class you've got one to try with Mr. Federico. Bye.